Hi everyone, we're students from Jose State and we're studying under the College of Engineering. We're currently in CMPE 243 under Pre. So in this class, our class objective was to create a self-driving car. Basically what that turns out to be is an RC car with a fully functional GPS and compass, as well as an external app that we can program the car as. So our car also has obstacle avoidance. It uses an array of sensors in the front and the back to detect obstacles and avoid them. So while driving to its objective given to it by the GPS, the car will avoid obstacles and pedestrians and will reach its destination successfully. So we are the Geo team. My name is Ryan Marlin.
Rishikesh. I am Bhushan.
Hi guys, myself Lee Peng.
I'm Preeti.
We belong to the master controller for the car.
We've worked with the master controller, which acts as a brain of the car. The master controller receives data from every single controller, processes it, and that's how it controls the way the car runs.
Thank you.
Hi, I am Nagma
Hi, I'm Shashank.
and we are motor team.
We have worked on two motors. Basically, one is servo to control the direction of the car, and the other is the brushless motor, which is controlled using ESC.
And also we attached a speed sensor to the back motor which gives us speed value in real time.
Hi guys, we are sensor team. My name is Deepak. He is Vinod. We worked on the sonar sensors for this car. These are the front sonar sensors and these are the back sonar sensor. They worked on pulse width, so we just measured the time between when the sounds comes back from the reflected from the obstacle. That's what we did, and this is an awesome project.
Hi, this is Sri Harsha and
I'm Srinam.
we are part of the IO team and we are responsible to display all the important data on the LCD screen.
This is the LCD screen, and here we have displayed the sensor values as well as the GPS values, and we have also set the predefined destination as a button so that the car will move to that point whenever we press it.
Hi everyone, my name is Chapinson. I'm part of the bridge team and my partner is Johnny and Kevin. And I made the app, Android app to communicate with car and take responsibility to tell car where to go.
Hi everyone, we are the team who made this Optimus Prime. It's basically a self-driven robot car that goes to the destination based on the GPS values and also detects any obstacles in between, like pedestrians or any other obstacles that comes in the way. We are a team of 15 people and are divided into 6 sub-teams. These 6 controllers represent the 6 sub-teams. The front right board is sensor controller, front left is the bridge controller, middle left is the geo controller, middle right is the master controller that controls the car, back right is the motor controller, and back left is the IO controller that controls the LCD. So this is the way it works. We have 3 sonar sensors in the front and 1 in the back. They detects an obstacle and gives its distance in inches. The sensor controller receives this data and passes it on to the master over the CAN bus periodically at 10 Hz. We have our geographical controller here, which gets data from GPS breakout board and also compass on the top. Here we get the distance to the destination, heading degree from GPS and current bearing degree from compass. They are given to the master periodically through the CAN bus at 10 Hz. The master processes the data from geo and sensors together to run the car. We have the bridge controller here that deals with the Android app and the Bluetooth B here. We use the Android app as a wireless interface to the car. Through this app, we can control several functionalities of the car that will be discussed in detail shortly. Next one is our IO controller. This controls the LCD display and has a switch to send the car to a fixed destination. It also controls this LED strip for multiple purposes. The LCD displays all the values like all the sensor values, the GPS and the compass values, and the speed of the car and number of messages per second the IO controller receives over the CAN and can be extended. Finally, here is our motor board. It deals with the speed and direction of the car. The servo at the front controls the direction and the brushless DC motor at the back controls the speed of the car based upon the duty cycle of the PWM signal. All the boards work on the CAN bus structure. Here is how our final products look like. We get real-time data from compass, GPS and an array of sensors in the front and the back, and the car goes by the destination values and obstacles.
Okay, hi. We'll demonstrate our Android app to communicate with our Optimus Prime. Now we connect to the car. You can see the button turn screen. That means the connection is established. Then you can see there's some value here. The value means the front sensor and back sensor and some information about speed and the direction. Okay, you can see the value here means our left sensor. This value means our center sensor. This one is the right sensor. And you can see the counter mean how much data that we collected from the car. And this value means our back sensor, and this is the speed. Since it's stopped, so the speed is 0. Then next block is our GPS information. This one is our bearing from the start point to the destination degree, and this 48 means the distance in meter, and this one you can see the value jumping around from 224 to 225, and that means our heading degree, and this one is the difference between our heading degree and the bearing angle. Okay, and you can see there's a small campus around here. Okay, next page is the map mode. In this mode, we can set that destination and let our car goes. First, we can get our car's location here. Then we can set everywhere we want to go. For example, here, then we press destination. Then you can see there's the text field with the location with the destination. Then we press route. The route will send our source and destination to Google API. Then Google Map will send us several waypoints. So because you can see we start from here to here, there's a building in between the location, so we have to take several turns to our location. Okay, so send. They will send several waypoints to the car. Then you can see the button go turn screen. That means our waypoints are successfully sent to the car. Then we can press go. Then the car will start.
Hey guys, this is Rishikesh and this is Bhushan. We are from the team 3OP and we are going to demonstrate the working of this car. To get started with, we have a Bluetooth app, Android app, which is going to get linked with the Bluetooth module on the car. This is the main UI of the app. Link to car will link it to the car, and we would be getting all the data which are being sent from all the boards to the master on this UI. We need to route it to a destination. Currently we are at position A. We would be going to the destination. This is the routed route, and we are just going to send it to the master. Green turn, this means that all the waypoints are received.
So we are at the music school now. We'll be going to the student union now, and we start the car.
Now the distance is 0, so the car stops. This is the student union, and it stopped at student union.